That's right. Let's look a little deeper at gravitational potential energy today. Any object that has a certain height from the ground has gravitational potential energy. Firstly, imagine you are in a wrestling match. A pro wrestler that has a mass of 100 kilograms jumps off a 1 meter tall pillar and slams you on the ground. How would you feel?
I'd be in extreme pain, I think. But I'd probably still be alive.
What if the same wrestler jumps off a 2 meter pillar and slams you onto the ground?
Gosh, it would definitely be more painful and I'd have a few broken bones. But can I survive it? Probably yes.
This time round, imagine a sumo wrestler with a mass of 200 kilograms do the jump at 1 meter and flatten you the same way as the wrestler.
I'd be dead. And it would probably be the most painful death ever.
Well, we can see it in this way. The pain you feel represents the energy transferred. See the link?
Is it like this? The gravitational potential energy of the wrestler is directly proportional to his mass.
Correct.
Similarly, the gravitational potential energy is also directly proportional to the height he jumps off.
Very good. In fact, it can be calculated with a very simple equation. Gravitational potential energy is equal to mgh, where m is the mass in kilograms, g is the gravitational constant, and h is the change of height of the object in meters.
Oh.